this video we're going to discuss surds. What is a surd and what is not a surd. So very briefly I'm going to remind you of square numbers. It's a good idea to memorize your square numbers. 1 squared is 1, 2 squared 4, 3 squared 9, 4 squared 16, 5 squared 25, 6 squared 36, 7 squared 49, 8 squared 64, 9 squared 81, 10 squared is 100, 11 squared is 121. There are a couple others that come up frequently. 12 squared 144, 13 squared 169. It's a good idea to recognize these numbers because when you see them, you'll recognize them as a square. So you'll know what their square root is. Square root is the inverse of square, so it's the opposite function of squaring a number. So I'm going to leave them up there to help us. Now the definition of a surd, it's an irrational number. It's a number that is not going to give us a whole number answer. So if we have, for example, square root of 4, we know that the square root of 4 is 2, because 2 squared is 4. So that is not a surd. The square root of 3 is not one of our square numbers, so it is a surd. I'm going to give you a little one here. There are some interesting things you can do with surds. Basically, apart from the number 1, which is not prime anyway, you will not find a prime number as a square number. It's not possible because it's always a number times a number. So if it's prime, it will be a surd. So 17, 21, 7 times 3. What we're going to look at is factoring, and you'll notice that in the files for today, in the notes for today, there is a thing about factor trees. And what we're going to do is break down our surds into its factors. I'm going to take them all the way down to the prime factor, but if you can find a square earlier, you can solve it faster. So, if I have root 72, I need to break it down into its factors. 72 is 2 times 36. So I could do 2 times 36. Now I know that 36 is 6 squared, but as I say, I'm using this as an example. So I can also say that it's 2 times 6 times 6. I can say it is 2 times 2 times 3 times 2 times 3. What we've got here is the prime factors that make up the number 72. So if I put them in order, we've got 2 times 2 times 2 times 3 times 3. We could write that as 2 cubed, 3 squared. We're not going to, but it is a possible way of writing them. What we're actually looking for here is pairs. So we've got a pair here, and we've got a pair here. And what happens is pairs come out the front, but they come out the front as their single digit because we are square rooting them. So what we get is 2 times 3 out the front, square root of what's left. 2 times 3 is 6. So we've got 6 root 2. Now if you look back up here at 6 times 6, or at 36, which I said was 6 squared, at that point we could have taken the 6 out the front. And we'd have got the same answer, 6 root 2. Okay. So I'm going to give you another example, and then we're going to manipulate them a little bit. So if we were given root 27 and asked to simplify it, we would know that 27 is 3 times 9, which could be written as 3 times 3 times 3. There's my pair. So I bring that out the front, I have 3 root 3. If I was given 2 root 75, I've already got a number set out the front. It doesn't matter. It can stay there and we will multiply it by whatever we can pull out. So I know that 75 is 3 times 25. So I've got 2 root 3 times 25. Now 25 is here, one of our square numbers, which is 5 squared. So what I've got is 3 times 5 times 5. I've got a pair, so that 5 comes out the front. So I have 5 times 2 and the root of what's left, which is 3. 5 times 2 is 10, so I have 10 root 3. You can do this with any number. And when we're in class, I'll have you shout random numbers and we shall try and find the simplified surds for them. Right. Now that's not all you can do. You can also add surds together, but they have to be the same surd, the same number inside the square root. So looking back at that root 27, if I have root 27 plus 2 root 3, if you remember, I worked out 27 as 3 times 9. The 9 is 3 squared, so I have 3 out the front. 3 root 3 plus 2 root 3. Now this is where knowing a little bit of algebra is handy. If you think of this as your x's, root 3 is equal to your x, then you've got 3 lots of x and add 2 lots of x. 3 plus 2 is 5, so we have 5 lots of x, and our x is really root 3. So you can add as long as the square root is the same. To give you another example, root 40 plus 4 root 10 plus root 90. 40 is 4 times 10. 4 is a square number. So what we've got, 4 times 10. So we know that 4 would come out as 2. 2 root 10. We can't do anything with this 10. It's 2 times 5. They're both prime numbers. We can't go any further. And 90 is 9 times 10. 9 is one of our square numbers. Square root of 9 is 3, so we've got 3, 10. Now if we do our sum, 2 root 10 plus 4 root 10 plus 3 root 10. 2 plus 4 is 6, plus 3 is 9, so our answer is 9 root 10. There's a couple of ways we can write surds as well. You have seen me write, I'll just do that one again, 90, as 9 times 10. I could have also written it as root 9 root 10, because a surd times a surd just becomes a combined surd. So if I had, let's see, if I have root 2 times root 12, what I have is root 2 root 12, or 2 times 12, which is 24. But if you're going to simplify them, you might as well simplify them further up. So I'll just show you on the side here an alternative method of getting to the final answer without having gone up the way first. So we've got root 2 times root 12. We know we've got a root 2. And we know 12 can be broken down into its component parts. So we know it's 3 times 4. So it's 3 times 4. 4 is a square number. So we know we're taking a 2 out the front. So we have 2 root 2 root 3. And at this point we can combine these two because we don't have any more pairs. So we have 2 root 6. If you look back at this one, if we'd taken it down into its component parts, we would have had the same numbers. Take it right down to its prime factors, we would have 24 is an even number, so it's going to be divided by 2. I'm going to change my layout slightly. So we've got the root 2 there. So it's 2 times 12. 12 is also an even number. So 2 times 6. 6 is also an even number. 2 times 3. And there we are. 2 times 2 times 2 times 3 is 24. And again, we're looking for pairs. And we can take a pair out the front. So 2, and then we've got 2 times 3 inside 2 root 6. Two methods to the same answer, but in an exam that one's slightly longer, so you want to be practicing the shorter version.